Today we're going to continue working with proof, focusing more on geometry proof, working with proving angles congruent. So again, using some things that we've talked about with angles before, but actually being able to prove that what we've learned is actually true. So the first proof that we have says to use the diagram at the right to complete the proof that the measure of angle ACD is equal to 130 by filling in the missing steps. So again, a lot of the work has been done for you. We just need to fill in some of those missing reasons. So our first statement says that the measure of angle ACB plus the measure of angle BCE is equal to 180. How do I know that those two angles would have to equal 180? They're not vertical angles. How do I know that these two angles have to equal 180? Pardon? Not when we don't have a given statement here. No. Okay, they didn't give that to us. Okay. If they tell us that and we use it in the proof, then it's given. This isn't given. How do I know that looking at my picture? What? Okay. So what am I using here? What did we learn in chapter 1 that we're using there? What are we doing with those angles?
Angle addition postulate.
Okay. We're using our angle addition postulate. Because they form a straight line, they make that linear pair, we know that they have to add up to 180. Okay? So we're using our angle addition postulate. What is our reason to moving to statement B? That's our substitution property. So even though the next statement and reason are both given, it's important for you to look at what is being done, because it's important to remember that a proof flows just like a paragraph. So we can't just look at piece at a time. We have to look at what is happening step by step. So to go from B to C, okay, they're telling us they combined like terms, and we can see that they combined that 5x and 9x. As I mentioned yesterday, if it helps you to understand what's going on, to actually mark in those statements, pencil in things in between, that is completely okay. Okay, so that we can see that process. Okay. So then going from C to D, what is happening? Okay, we're subtracting 40 on both sides. So we're using our subtraction property. To go from D to E, we divided both sides by 14. So division property, they're actually being even more specific and saying of equality. we're not going to require you to put that, but you do need to have division property. So then statement F looks different. They're telling us that we're using substitution property. How are we using substitution property to write down a statement F?
Substitute 10 in for X.
Yes, because it's the same as step B, but they're already combined.
Okay. So what we're doing is making some substitution. We're not substituting into B. Okay. We're substituting into what we were given for that particular angle. Okay. Angle BCE is the 9x plus 40. So that's where we're substituting in. We have 9 times 10 plus 40, and then we worked it out to be 130. Okay? So we substituted the 10 into this value for that angle. Okay? Angle BCE. Number G, or letter G, says that angle BCE is congruent to angle ACD. Okay. If I look at my picture and look at those two angles, angle BCE is the blue angle. Angle ACD is the yellow angle. So how do I know those two angles are congruent? Okay. They are vertical angles. So we need to write vertical angles. Okay. For angles, we can use the angle symbol with a letter inside, the letter S. So vertical angles are congruent. We can use the congruent symbol. Vertical angles are congruent. And then H says that angle ACD is equal to 130. And they said the substitution property. So what we did, okay, in statement F, we said angle BCE is equal to 130. Okay. So we're taking the 130, we're substituting it in place of angle BCE to get to ACD equal to 130. Okay. So when we work with geometry proof, okay, when we're working through that algebra part, okay, that algebra part goes step by step. But then some of the other things, it could be combinations of steps that we're combining together, okay? It could be something from up higher in that list of statements, okay? It's not just necessarily from the previous statement to the next. Sometimes we're combining things as we go through. So again, it just takes lots of practice, just reading through those, because you're going to see as we go through proofs, even though the actual thing we're proving is different, okay, you're going to see lots of similarities as to how these things fit together. So just reading through those proofs over and over again is going to be helpful to you. In this next proof, it says to complete the following proof by filling in the blanks. So we've got our given statement, okay, that angle 1 is congruent to angle 2. So just like we talked about yesterday, That's what we start out our proof with. That first statement, angle 1 is congruent to angle 2. Our reason is given. Anytime we have that information given to us or we get to it in a statement, it is often helpful to mark it in the picture. So I'm going to mark in the picture that angles 1 and 2 are congruent to each other. We are working towards proving that angle 3 is congruent to angle 4. So we have to work through that process. So our second statement says that angle 1 plus angle 3 plus angle 5 is equal to 180. So if I look at that in my picture, angles 1, 3, and 5 added together are going to equal 180. How do I know that those three angles are going to add up to equal 180?
Because angle 5 is 90 degrees.
That doesn't mean that all three of them are going to equal 180. You just looked at this in a previous proof. What am I doing when I'm adding those three angles together? It's our angle addition postulate. Those three angles are forming a straight angle, which is 180 degrees. Angle addition postulate. Number 3 says angle 1 plus angle 3 plus 90 equals 180.
Substitution probably.
Okay?
Because you know
That would
5
be
is 90.
substitution, right? Okay? We're changing. Okay? If we look at what changes here, okay? Instead of saying the measure of angle 5, which we know is 90, so we substitute that number in. So that is our substitution property. Statement 4 says the measure of angle 1 plus the measure of angle 3 equals 90. Okay. I am subtracting 90 from both sides. So I'm using the subtraction property. Statement 5 says the measure of angle 4 plus the measure of angle 2 is equal to the measure of angle 5.
Is that vertical angle with the roof?
Very good. Okay? So it's not flowing with what we were doing before. This is looking at something completely different. Okay? We're shifting gears. If we look at our picture, okay, angle 5 and angles 2 and 4 put together are vertical angles. So vertical angles are congruent. Step 6. What are we doing?
Substitution.
Okay, similar. So again, we're doing something similar to what we did up above. So instead of saying angle 5, we change that to 90. because again, our picture indicates that's a right angle. So again, we are using our substitution property. Number 7. What's changing to go from 6 to 7? What did we change from 6 to 7? We changed from angle 2 to angle 1. How can we do that?
Because 2 and 1 are the same.
Okay, because up in statement 1, we said angles 1 and 2 are congruent. So when we come down here, we are making a substitution. Number 8. Okay. This last one is something that we have not talked about before, something that is new to this particular unit. Okay. So if I look at statement number 4, okay, it tells me that angles 1 and 3 equal 90. Okay. If 2 angles equal 90, what do we call those angles? Okay. Complementary. So they're complements. Okay, they're complements of each other. Okay, they're complementary angles. So we say angle 1 is complementary to angle 3. Angle 3 is complementary to angle 1. So angles 1 and 3 are complementary. When I look at segment or statement 7, I know angles 1 and 4 are complementary. Okay. So 1 and 3 are complementary. 1 and 4 are complementary. So because they are both complementary to the same angle, then 3 and 4 would have to be equal to each other. Because if 1 and 3 equal 90, okay, we could put in any numbers that we wanted to. Okay, if angle 1 was 30, angle 3 would be 60. Okay, if angle 1 is 30, angle 4 would be 60. 3 and 4 would be equal to each other. Okay, and what we call that is congruent complements. Congruent complements. So because we had 2 groups of complementary angles, okay, because they both had a 1, then that means that the 3 and the 4 would have to equal each other. Okay. So by using congruent complements, by knowing that now and being able to use it, it just saves us a lot more time. We could get to this angle 4 equals angle 3 another way by using a lot more substitution, subtraction property, all that kind of thing, but it would take us probably 5 or 6 more steps to do so. Okay? So if we can identify that we have those 2 complementary statements then we can use this idea of congruent complements to save us some time and some steps in that proof. Next one. Again, we've got a 2-column geometric proof. We've got a given statement. We've got a prove statement. If you look at our diagram, this one's a little bit different than what we've seen before because we don't have any algebra that we're going to be doing in this problem. Okay? We don't have any angle measures in the picture or anything else. This is completely geometry, looking at relationships between different pieces. Okay? So we've got our given statement and our prove statement. We've got that diagram that's going to help us. So what's going to be our first statement? Okay. We're going to take that given statement, measure of angle BOF equals the measure of angle FOD. That's given. Again, first thing I want to do is mark that in my picture. Angle BOF and angle FOD are congruent. Statement 2 says that the measure of angle BOF plus the measure of angle FOD is equal to the measure of angle BOD. How do I know that I can add those pieces together? Substitution is when we're substituting in something into something we already have. What? Angle addition postulate. 2 small angles equal the big angle. Angle addition postulate. Number 3. Okay. So sometimes you have to look really closely to see what's changing. So what changed from 2 to 3? Okay. Angle FOD became angle BOF. Why can we change that? Okay, we can change it because of statement 1. Statement 1 says those 2 angles are equal to each other. So we are putting that in here, which means we are making a substitution.
What is the point of that?
What's the point of making that substitution? Okay, because if we are looking ahead at what we want to prove, where we need to end up, okay, what we need to end up with has nothing to do with angle FOD. Okay, so we need to get FOD out of there. Okay, when we're done, we only want those 2 players in the game. Okay, so we had to get angle FOD out by using our substitution property. Next thing, we need a statement. Our reason's going to help us. It says to combine like terms. What like terms do we have to combine? We have like terms, so when we combine them, what do we have? Okay, 2 times the measure of angle BOF equals the measure of angle BOD. So we combined like terms. Next thing, all of a sudden now they've thrown in a different angle. They're throwing in angle AOE. So I'm going to look up in my picture. Angle AOE is that red angle. Angle BOD is this yellow angle.
Vertical angles are congruent.
Very good. Vertical angles are congruent. Vertical angles are congruent. Number 6 says definition of congruence. So what does it mean for things to be congruent?
They're equal.
They are equal to each other. Their measures are equal. So if these statements are congruent, their measures, the measure of angle AOE equals the measure of angle BOD. And then I know my last step involves substitution. What is that last statement?
2 times the
Two
measure of angle BOF.
Okay. Because what we're doing, substituting, is we're using statements 4 and 6. Okay. So BOD is the same thing as 2 times the measure of angle BOF, okay? Which is what we're trying to prove. That last statement needs to be what we're trying to prove. Okay, if we're not there yet, then we have to add more steps, but we can get to that. So 2 times the measure of angle BOF is equal to the measure of angle AOE.
Why do you just put BOF back in here?
Because that's what we're trying to prove. So we have to put it, we have to substitute it in. Okay? Because that's what we're trying to prove. Okay? That this big angle is the sum of those 2 angles added together. Okay, so 2 times BOF is going to equal angle AOE. Okay, that's what we're trying to prove. So we just have to step through to get to that statement. There's lots of things that we could do with that picture. Okay, but a proof is, given this information, what can we use that we already know to be able to prove that this statement is true? So that's what a 2-column proof is doing.
So the proof is going to be the last one. No matter what.
Right, that proof statement needs to be where we are ending. Yep, that's how we know we're done once we get to that final prove. Okay? What doesn't happen is that your reason, okay, we get students that automatically put this down here, and then for the reason they want to write prove. Okay? We don't use prove. Okay? We use given, okay, but we don't use prove as a reason.
That's smart.
Okay?